On arriving at Los Amigos, the presence of a large leaf-cur ant population was highlighted to us by Dr. Ross Piper. Leaf-cur ants have large colonies that inhabit vast underground nests. The top of the central mound to these nests is visible from the surface, as the surrounding vegetation has been cleared away and the ground appears raised. Leaf-cur ants cut and process fresh vegetation from the surrounding area and carry it back to the nest via paths that they have cleared in the undergrowth. However, the ants do not feed off these leaf pieces directly, and instead use them to cultivate a fungus within their nest that acts as their food source.
To measure the distribution of the miners, we recorded the ants carrying leaves, and leaves with miners on. A full line denotes an ant without a leaf, a half line represents an ant with a leaf, and a half line with a dot on top symbolises a leaf with a miner present. We did 10 replicates of 1 minute, 3 times a day, morning, midday and evening. We recorded the information by having one person observe and then relay to another person who records the information down. This data measures the level of ant activity, how closely spaced the miners are, and how closely spaced the leaves are.
As with distribution, we had one person observing and one person noting when measuring the frequency of miners to leave.
Leaves, ants, ants.
The person observing called out the number of miners on each leaf that passed, and the person noting recorded both the number of leaves and the cumulative frequency of miners. We did 2 replicates of 50 leaves at each recording time.
We conducted one-way ANOVA and LSD post-hoc tests on our data, which showed that there is no significant difference between the ratio of miners to leaves at the times of day measured. However, we found significant differences between morning, afternoon and evening for both ants per minute and mean distance in ants between leaves, with the shortest distance and most activity at night. Finally, we found a significant difference in the mean distance in ants between miners in the evening and the other times of day, with a distance of 5.9 in the afternoon and 18.1 in the evening.
As well as our main findings, we also took note of a few novel observations throughout our data collection. Firstly, we noticed that all termite presence was wiped out around the paths from the main colony to the harvested trees, as well as the paths being flattened and cleared of any obstructing vegetation. A behaviour actually observed by us, where a worker ant cut down an obstructing twig over the path. The miner ants also often disembark their leaf at the last junction before the main colony, returning towards the harvested tree, checking the heads of the worker ants for parasitoid fly eggs along the way. It was also at this point that we observed that more often than not, the leaves with miner ants on had multiple miner ants on them. The general activity of the ants greatly changed depending on the time of day and temperature. At high temperatures during midday, the activity of the ants was low, possibly to avoid exhaustion from the high heat. The activity of the ants then increased throughout the day, peaking at 1 AM when multiple trees were being harvested, the ants exploiting multiple pathways joining to the main one, with a one-way on and off junction to improve efficiency.
From our data, we can conclude ants are the most active in the evening, followed by the morning, then the afternoon. Also, there is no relationship between the ratio of miners and the time of day. Furthermore, leaves are more closely spaced in the evening, followed by the afternoon and morning. In terms of spacing, miners are further apart in the evening than the afternoon. There were no miners recorded in the morning. Parasitoid flies are diurnal, so this spacing may be because parasitoid flies are least active in the evening and night. Further research would need to be conducted to ascertain whether the activity of parasitoid flies immediately affects miner distribution. Contrary to this, our data shows that leaves are more clustered in the evening, so that miners can guard more leaf-carrying ants at once. Therefore, to conclude, we can reject the first null hypothesis, but must accept the second. If we were to repeat our experiment, we would undertake our measurements at other times of day, as the pilot time of 10 AM was more successful for measuring frequency as there was a higher number of miners measured. Overall, although further research is needed, our experiment was successful in highlighting a relationship between time of day and distribution of miners.